Hello students and good morning. So now I am doing class for class 12, the same topic that we were doing in the last online class, that is integration by the method of substitution. So same exercise, that is exercise 6a, page number 351, 4 marks section from the book Higher Mathematics for class 12 by S&A. So let's start this question number 23. So it is given, you have to find out the integral of x to the power 6 divided by x minus 1 dx. So how will you do this integration now? So therefore I is equal to integration of x to the power 6 divided by x minus 1 dx. Now in this case, what is the highest power of x in the numerator? It is 6. And what is the highest power of x in the denominator? That is 1. So if the highest power of x in the numerator is more than the highest power of x in the denominator, then divide the numerator by the denominator. So in this case, the highest power of x in the numerator is 6 and the highest power of x in the denominator is 1. So you have to divide this numerator by denominator. Okay, so let us divide it. So x minus 1 will divide x to the power 6. Let us divide it. So now there is x. In order to get x to the power 6, this x should be multiplied by x to the power 5. So it is x to the power 6 minus x to the power 5, right? So you have to change the sign, you have to subtract it, minus plus. This x to the power 6 will be cancelled. So it is only x to the power 5. So again you have to multiply it by x to the power 4 to get x to the power 5. X to the power 4 into x is x to the power 5 minus x to the power 4. Again subtract it. This is minus plus. This gets cancels. So you will get x to the power 4. So again you can write here plus x cube plus x cube. X into x cube, that is x to the power 4. Then minus x cube. Right? So next change the sign, minus plus, this will be cancelled, then comes x cube, again plus x square, again plus x square into x cube, then minus this is x square, so it is minus plus x cube gets cancelled, so you will have x square, again it goes x times plus x into x square plus into minus x, so it is minus plus, so here x square gets cancels, so it is x. Now again there is x, here is also x, so it goes one time, so 1 into x is x, minus 1, so it is minus plus, here x gets cancels. So now what is the remainder here? 1. So since this remainder is free from x, so you cannot divide this one by x minus 1. So this is the remainder 1. So you know how to write it, isn't it? Suppose if you divide 7 by 2. Suppose you have 7 by 2. So how will you divide this 7 by 2? So how will you divide this 7 by 2 now? So it is 2 3s as 6. What is the remainder? Remainder is 1. So that you can write it as quotient plus remainder upon divisor. This 3 is known as the quotient, 1 is the remainder and 2 is the divisor. So this 7 by 2 can be written in the form quotient plus remainder upon divisor. That is 3 plus half, right? So here also you can write here I is equal to integral sign. Let us write within bracket. So here we have divided this numerator by denominator. What is the quotient now? Let's start from 1 plus x square plus x cube plus x to the power 5 plus x to the power 5. Okay? Then this is the quotient plus remainder upon divisor, isn't it? That is numerator divided by denominator is equal to, how will you write it? That is quotient plus remainder divided by divisor. You know how to write it, isn't it? That is numerator divided by denominator. If you divide the numerator by denominator, you can write it in the form quotient plus remainder upon divisor. So this is the quotient here, plus what is the remainder? 1 divided by what is the divisor here? It is x minus 1. Bracket close, then you can write dx. So I think you have understood it. Okay, so now you can separate the term and then you can easily integrate them. Or I is equal to integral sine 1 into dx plus integral sine x dx plus integral sine x square dx plus integral sine x cube dx plus integral sine x to the power 4 dx plus integral sine x to the power 5 dx, and what is the last one? Plus integral sine, it is dx upon x minus 1. So you can easily integrate them now. Or I is equal to, what is integral sine dx? X. What is integration of x? X square by 2. What is integration of x square? X cube by 3 plus what is integration of x cube? X to the power 4 by 4 plus what is integration of x to the power 4? It is x to the power 5 by 5 plus what is integration of x to the power 5? X to the power 6 by 6 plus what is integral sine dx upon x minus 1? This is log within mod x minus 1. The base is e. Since here the power of x is 1, so you can take this x minus 1 as x, so that you can easily integrate them. So what is integration of 1 by x dx? That is, it is log x, but here x is x minus 1. So whole divided by differentiation of the function which is assumed as x. That is, what is the differentiation of x minus 1? That is 1. So it is whole divided by 1. Then you should write here plus c, where c is a constant of integration. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question. Before that, you can do these two problems at home. You can do it similarly as we have done in the previous one. That is integration of x to the power 5 divided by x minus 1 dx. Similarly, you can divide this numerator by denominator. Here also the same same type of problem is there. Integration of x to the power 7 divided by x minus 1 dx. Here also you divide x to the power 7 by x minus 1. Okay. So now in this case, if you divide x to the power 5 by x minus 1, what will be the quotient? The quotient will start from 1 plus x square plus x cube plus you can write up to x to the power 4. That is 1 less should be there. There is x to the power 5 is there. So the power should be 1 less. That is 1 plus x square plus x cube plus x to the power 4 plus 1 upon x minus 1 will be there. So similarly, you can divide this x to the power 7 by x minus 1. What will be the quotient here? If you divide x to the power 7 by x minus 1, what will be the quotient? 1 plus x square plus dot dot dot, it goes up to x to the power 6, then plus remainder upon divisor, that will be 1 upon x minus 1. So similarly, you can do these two problems as we have done in the previous one. Okay, that is in question number 23. So now let's do this question. And this question is from HS 2010. This question is from HS 2010. So what is the question out here? You have to integrate x to the power n divided by x minus 1 dx, where n is a positive integer. So it is the generalized question. So it n may be 1, n may be 2, n may be 3, n may be 4, and so on. Okay. So here also, if you divide x to the power n by x minus 1, the quotient will be, it will start from 1. 1 plus x square plus dot dot dot, it goes up to plus x to the power, decrease the power by 1 here. In the previous problem, we had x to the power 6 divided by x minus 1 dx. So if we divide x to the power 6 by x minus 1, what will be the quotient out there? It is 1 plus x square plus x cube plus x to the power 4 plus x to the power 5. That is, the last number will be x to the power 5 starting from 1. That is, decrease the power by 1 here. So it will be x to the power 5. This will be the quotient plus remainder upon divisor. Is that clear? So similarly here also we can divide it. So therefore I is equal to integral sine x to the power n divided by x minus 1 dx. Okay. Now in this case, if you divide this numerator by denominator, what will be the quotient in this case? Here also the quotient starts from 1 plus x square plus x cube. There will be x to the power 4 plus x to the power 5 plus x to the power 6 and so on, and it goes up to plus x to the power n minus 1. So here the power of x is n. You have to decrease the power by n. That will be the last one, that is x to the power n minus 1 plus, what is the remainder? Remainder is 1, similarly divided by x minus 1. Then what do you write here? It is dx. So I think I have understood. Directly you can write it. As in this case also you can directly write down, or you can divide it, but here n is the general number. So if you divide x to the power n by x minus 1, you will get the quotient as 1 plus x square plus x cube plus dot plus x to the power, decrease the power n by 1, that is x to the power n minus 1 plus remainder upon divisor, then dx. Okay. So now let us separate the term integral sine dx plus integral sine x dx plus integral sine x square dx plus integral sine x cube dx plus dot plus integral sine x to the power n minus 1 dx plus, what is the last one? That is integral sine, this is dx upon x minus 1. Okay. Now we can easily integrate them, or I is equal to, what is integral sine dx? That is x plus, what is integration of x? X square by 2. What is integration of x square? X cube by 3. What is integration of x cube? X to the power 4 by 4 plus dot plus. Now what will be the integration of x to the power n minus 1? It will be x to the power n minus 1 plus 1, isn't it? Divided by n minus 1 plus 1. That means you will get x to the power n divided by n. It will be x to the power n divided by n. So how did you get this one? X to the power n minus 1 plus 1 divided by n minus 1 plus 1. That will be x to the power n upon n plus. So what is integral sine dx upon x minus 1? It will be log of x minus 1. The base is e, whole divided by 1 should be there. That is the differentiation of the term which is assumed as x. That is, differentiation of x minus 1 will be 1. So whole divided by 1, you don't have to write it. Then what should you write? Plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 26. You have to integrate integral sine x cube plus 3x square plus 2x minus 7 whole divided by 2x plus 1 dx. So here also, what is the highest power of x in the numerator? It is 3. And what is the highest power of x in the denominator? It is 1. So I already told you that if the highest power of x in the numerator is greater than the highest power of x in the denominator, then you should divide the numerator by denominator. Okay. So first of all, let us write I is equal to integral sine x cube plus 3x square plus 2x minus 7 whole divided by 2x plus 1 dx. Okay. Now let us divide. Let us divide the numerator by the denominator. So here this denominator 2x plus 1 will divide the numerator x cube plus 3x square, x cube plus 3x squared, then plus 2x minus 7, isn't it? Plus this is 2x minus 7. Let us divide it. So now, since there is 2x and here it is only x cube, by which number or which expression will you multiply 2x to get x cube? These 2 will be cancelled. So x square into x will be x cube, and this 2 will be cancelled, that is divided by 2. So what is 2x into x square by 2? This will be x cube plus 1 into x square by 2 is, this is x square by 2. So let us subtract them. This is minus minus. So this x cube will be cancelled. What is 3x square minus x square by 2? 2 3s are 6 minus 1. That is, it is 5x square by 2 plus 2x minus 7. Is that clear? So next, what will you do? Here the coefficient of x is 2. Here the coefficient of x square is 5 by 2. By which number or by which expression will you multiply this 2x to get 5x square by 2 plus 5x upon 4? So 2 into 5 by 4 will be 5 by 2, and x into x is x square. You will get 5 by 2 x square, right? So 2x into 5x by 2 is 5x square by 2. Then plus this is 5x by 4 into 1 is 5x by 4. Then it is 5x by 4, right? So now you can subtract it. This is minus minus. This will be cancelled. So it is, what is 2x minus 5x by 4? This is 4 2s are 8x minus 5x. That is 8x minus 5x is 3x by 4 minus 7. I think you have understood it. Next, there is 3x by 4 and here is 2x. By which number or by which expression will you multiply this 2x to get 3x upon 4? You will have plus 3 by 8. If you multiply 2 by 3 by 8, 2 4s are 8, 3 by 4, and x is there. So it is 3x by 4, and then plus into plus, plus 1 into 3 by 8, that is your 3 by 8. Is that clear? Now you can subtract it. This is minus minus. This will be cancelled. So minus 7 minus 3 by 8, same sign, you have to add them. Minus 8 7s are 56 plus 3. 8 7s are 56 plus 3 is 59. Minus 59 divided by 8. That is your remainder. So now you know how to write down this fraction. That is, we have divided the numerator by denominator. So you should write in the form of quotient plus remainder upon divisor. So or I is equal to integral sign within bracket. What is the quotient out here? Your quotient is x square by 2 plus 5x by 4 plus 3 by 8. This is the quotient. Plus, now you should write down the fraction. The fraction is remainder divided by divisor. What is the remainder here? It is minus 59 by 8 divided by, which is the divisor out here? It is 2x plus 1. Bracket closed. Then you can write dx. Okay. So numerator divided by denominator will get will give you this expression. Numerator divided by denominator. Numerator divided by denominator will give you this expression. Okay. Now you can separate the term. Or I is equal to, now you can separate it. Half integral sign x square dx plus 5 by 4 integral sign x dx plus 3 by 8 integral sign dx plus and minus. Minus this is 59 by 8 integral sign dx divided by this is 2x plus 1. Okay. So or I is equal to half into, what is integration of x square? It is x cube by 3 plus 5 by 4 into, what is integration of x? It is x square by 2 plus 3 by 8 into, what is integral sign dx? X minus 59 by 8 into. So what is integration of dx divided by 2x plus 1? Now in this case also 2x plus 1 is an algebraic expression, and here the power of x is 1. So you can take this 2x plus 1 as x. So what is integration of dx by x? That is your log x. But here it is log within mod, it is 2x plus 1, the base is e. Again, whole divided by, you should write down the whole divided by, in the denominator you should write down the differentiation of the term which is assumed as x. That is, you have to differentiate 2x plus 1 with respect to x, which is equal to 2. Then what do we write here? Plus c. Okay. So now or I is equal to, this is x cube by 6 plus 5 by 8 x square plus 3x upon 8 minus 59 by 8 2s are 16 log within mod, this is 2x plus 1, the base is e, then it is plus c. So this is the final answer. So you can copy it. Now we will do the next question. So now we'll do the next question, that is question number 27. So that is, you have to integrate integral sine e to the power 2x divided by e to the power x plus 1 dx. So let us write first I is equal to integration of e to the power 2x dx divided by e to the power x plus 1. So how will you do it? So how can you integrate it? Therefore I is equal to integral sine. Now in this case, in the denominator there is e to the power x plus 1. Okay, so write this expression in the numerator. In the numerator you write e to the power x plus 1 within bracket. Whatever is there in the denominator, you write it in the numerator, that is e to the power x plus 1. But here we have e to the power 2x is there. So by which expression will you multiply e to the power x to get e to the power 2x? E to the power x, isn't it? So you multiply it by e to the power x. Is that clear? So if you multiply e to the power x by e to the power x, you are getting e to the power 2x. But there is 1 again here. So e to the power x into 1 is e to the power x plus e to the power x is added there. But is there e to the power x there? No, you have to subtract it. So it is minus e to the power x divided by e to the power x plus 1. Then what do we write? Dx. Okay. Now you can separate this term, or I is equal to integral sine within second bracket e to the power x into e to the power x plus 1 divided by e to the power x plus 1. This e to the power x plus 1 will be cancelled. You will have e to the power x minus e to the power x divided by e to the power x plus 1 second bracket closed dx. So I think you have understood it. Now you can separate integral sine and dx also. Or I is equal to integral sine e to the power x dx minus integral sine e to the power x dx divided by e to the power x plus 1. I think you have understood it. Next, or I is equal to, now what is the integration of e to the power x dx, or differentiation of which function is e to the power x? That is here e to the power x minus, next, so how do you integrate this one? E to the power x divided by e to the power x plus 1 is in the denominator. That is, e to the power x divided by e to the power x plus 1 is there. So if you differentiate the denominator e to the power x plus 1, we are getting e to the power x which is in the numerator. So here you can use this formula. F dash of x dx divided by f of x. That is, differentiation of f of x is f dash of x. That is, differentiation of the denominator is the numerator. So what is the formula for this case? It is log within mod f of x base e plus c. So if the differentiation of the denominator is the numerator, we can use this formula. That is log of f of x base e plus c. Here f of x is e to the power x plus 1. And its differentiation will be the numerator e to the power x, isn't it? So what is the formula here? It is log within mod e to the power x plus 1 base e then plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 28. So this question number 28 will be a homework. I'll give you the hints only. You have to integrate integral sign within bracket x plus 1 whole divided by x bracket close into x plus log x whole square dx. So how will you do it? You have to check the relation between x plus log x and x plus 1 upon x. What is the relation between these two given expression? So if you differentiate x plus log x, what will you get? Differentiation of x is 1 plus log x differentiation is 1 by x. So LCM is x, so it is x plus 1 whole divided by x. That is, we are getting x plus 1 divided by x. So now in this case you can do the method of substitution. So first of all you write capital I is equal to given integration, then you can assume let z is equal to x plus log x. So you can use this method for integrating this particular integral. So you can do it at home. So let's do this question out here. Okay, so now you have to evaluate this integration. You evaluate this integration, that is integral sign dx divided by 1 plus e to the power mx. So therefore let us write here I is equal to integral sign dx divided by 1 plus e to the power mx. So now what is the method for integrating it? How will you integrate it? Now in this case, in the denominator 1 plus e to the power mx is there. This is your exponential function, but not the algebraic expression. So if there happen to be algebraic expression like x, 1 plus x, we could have assumed it as x, then you can use the integration of 1 by x dx, which is equal to log within mod x base e. But since this is an exponential function, you cannot assume it as x as we have done in differentiation. Is that clear? So there is different method for integrating this particular integral. So now what is the differentiation of 1 plus e to the power mx? For 1 it is 0, for e to the power mx it will be e to the power mx into m. Here m is constant. But what is there in the numerator? There is only 1. Before dx there is only 1, but it is not e to the power mx. So if in the numerator, if there was e to the power mx, we could have assumed 1 plus e to the power mx as z. यदि numerator मा चाहिँ e to the power mx भएको भए चाहिँ we could have assumed 1 plus e to the power mx as z. But there is 1 in the denominator, so you cannot use this method of substitution in this case. Okay? So now what is the method in this case now? The यसमा हामी कसरी integration गर्छौं भन्दा पनि there is a method here. Therefore I is equal to integration of dx divided by 1 plus, let us simplify it. Let us make it 1 upon e to the power minus mx. So whenever you have such type of question, 1 upon 1 plus e to the power mx, then you should make this term, that is e to the power mx, as 1 upon e to the power minus mx. We can do it, isn't it? You can simplify it like this. Dx divided by 1 plus 1 upon e to the power minus mx. If the expression is like this one, 1 upon 1 plus e to the power mx, let us make this e to the power mx as 1 upon e to the power minus mx. Okay, now let us simplify it. What's the LCM? Or I is equal to integration of dx divided by, let's take the LCM here. What's the LCM? It is e to the power minus mx. Okay, this is the LCM. So here you will have minus e to the power mx plus 1. This is just simplified. Okay, so now simplify it. I is equal to integral sine e to the power minus mx dx divided by e to the power minus mx plus 1. So I think you have understood it. Now in this case, if you differentiate the denominator, we will get the numerator in this case. Now differentiate e to the power minus mx with respect to x. What is the differentiation of e to the power minus mx? It is e to the power minus mx into minus m. But we are getting e to the power minus mx, isn't it? So you can use the method of substitution in this case. So let z is equal to e to the power minus mx plus 1. So let us write here, differentiating both the sides with respect to x. Therefore dz by dx is equal to, what is this differentiation? E to the power minus mx into, again differentiate minus mx with respect to x, it is minus m. Okay, so now cross multiply it. So dz is equal to minus m e to the power minus mx dx, or what is the value for dz now? Or what is the value for numerator, that is e to the power minus mx dx. Let us take this term minus m to the left hand side, or it is minus dz upon m, that is minus dz upon m is equal to e to the power minus mx dx, e to the power minus mx dx. Okay, so we have got the value of the numerator. So therefore I is equal to integral sine, what is e to the power minus mx dx? It is minus dz upon m, minus dz upon m divided by, what is e to the power minus mx plus 1? It is assumed as z. Is that clear? Next, or I is equal to, which is constant out here? Minus 1 upon m. Minus 1 upon m constant, integral sine, it is dz upon z. Okay, now you know what is the integration of 1 by z dz, or differentiation of which function is 1 by z, or I is equal to minus 1 by m log within mod z base e plus c, or I is equal to minus 1 by m log within mod, what is the value for z? Here the z is e to the power minus mx plus 1, e to the power minus mx plus 1 plus c. Here the base is e. So this is the final answer. So I think you have understood this problem. This question is not from the book, but these two questions 29 and 30 are from the book. But for this 29 and 30 problem, we can use this method. Okay, so this 29 and 30 will be your homework, right? So you can use the same method as we have done in this problem. So this problem are similar problem, 29, 30 and this one. Okay, so how will you do question number 29? Integral sine dx divided by 1 plus e to the power x by 2. It is just like your 1 plus e to the power mx. Your m is half. So how will you integrate it? Let us make it e to the power x by 2 as, let us write e to the power x by 2 as 1 upon e to the power minus x by 2. Then take the LCM, simplify it, and you can use this method. Okay, so this 29 is similar to this problem. Similarly, you can do number 30, integral sine dx divided by 1 plus e to the power x. Here also e to the power x, write it as 1 upon e to the power minus x, simplify it, and then use this method. Okay, so these two are your homework. You can use this method. Is that clear to all of you? So next, this question number 31 is easier than 29 and 30. So this is also your homework. You can do it. So what is the method here? Integral sine e to the power x dx divided by within its square root e to the power x plus 8. So first of all, you should check the relation between e to the power x plus 8 and e to the power x. That is, differentiation of e to the power x plus 8 will be e to the power x, isn't it? But since the square root is in the denominator, you can assume e to the power x plus 8 as z square, so that this square root can be removed. So this is the method of substitution. So you can do it at home. Okay, so this is also your homework. That is, this 28, 29, 30 and 31 will be your homework. So now let's do the next question now. So now we'll do the next question, that is question number 32. You have to integrate this function, that is integral of e to the power x dx divided by 1 plus e to the power 2x. So this question is very, very important. So let us write here I is equal to integral sine e to the power x dx divided by 1 plus e to the power 2x. So how will you do it? You cannot assume this denominator as z, because the differentiation of 1 plus e to the power 2x will be e to the power 2x into 2. But there is only e to the power x in the numerator, but we are not getting e to the power 2x in the numerator. Okay? But you know that differentiation of e to the power x is e to the power x. Okay? So we can make this, you can write this e to the power 2x as e to the power x whole square. Or I is equal to integral sine e to the power x dx divided by 1 plus e to the power x whole square. Is that understood now? So we can assume let z is equal to e to the power x, because differentiation of only this function e to the power x is e to the power x. So we can assume let z is equal to e to the power x. So let z is equal to e to the power x. Now let us differentiate. Differentiating both the sides with respect to x. So therefore dz by dx is equal to e to the power x. Or you can do cross multiplication, dz is equal to e to the power x dx. So I think you have understood it. So now this I becomes now I is equal to integral sine, what is e to the power x dx? It is dz divided by 1 plus e to the power x is z, that is your z square. So I think you have understood it. So now what will you do in this case? This is integration of dz divided by 1 plus z square. So can you assume 1 plus z square as z out here? You know that 1 plus z square is an algebraic function. I told you that whenever there is an algebraic function or the power of z or the power of x is 1 only, then you can assume it as x or z. But in this case, this is algebraic function, but the power of z is 2 in this case. It is z square. So you cannot assume this 1 plus z square as z. Is that clear? So here is the different method in this case. In this case, you have to do the method of substitution by trigonometry. Here you should do the trigonometric substitution. So in differentiation also I told you about this one. Whenever you have 1 plus x square, so either you can put x is equal to tan theta or cot theta. Is that clear? Whenever you have x square minus 1, and if you want to put, or if you are to put a trigonometric function, then you can put x is equal to sec theta or cosec theta. Okay? If you have 1 minus x square, what should you put for x? X is equal to sine theta or it may be cos theta. So I think you have understood it. So if there is 1 plus x square, and if you are to do the trigonometric substitution, you can put x is equal to tan theta or cot theta, because you know the formula for 1 plus tan square theta as well as 1 plus cot square theta, right? If you have x square minus 1, you can put either x is equal to sec theta or cosec theta if you are to do the trigonometric substitution. So if you have 1 minus x squared, then you can put x is equal to sine theta or it may be cos theta. But in case of integration, if you have 1 plus x square, we always put x is equal to tan theta only, so that its differentiation will be positive. So in case of integration, if you have to do the method of substitution or if you have to do the trigonometric substitution, you have to differentiate it again so that it will be positive. So if you assume x is equal to tan theta differentiation will be positive. So in case of integration, we put x is equal to tan theta, and if there is x square minus 1, and if you are to do the trigonometric substitution, we always put x is equal to sec theta so that its differentiation will be positive. Okay? If there is 1 minus x square, we always put x is equal to sine theta so that its differentiation will be always positive. Is that clear to all of you? Now, in this case, there is 1 plus z square. Instead of x there, here it is z. But it is z square. 1 plus z square is there. So what is the method now in this case? We can put trigonometric substitution. Let z is equal to tan theta. So let us put let z is equal to tan theta. So this is the trigonometric substitution method in this particular integration. Okay. So now you can differentiate both the sides with respect to theta. So differentiating both the sides with respect to theta. Therefore, what is dz by d theta is equal to differentiation of tan theta. You know that this is your sec square theta. Now cross multiply it. So dz is equal to, this is sec square theta d theta. So I think you have understood it. Okay. Now let us put these values in I. So therefore I is equal to integral sign. What is dz? dz here is sec square theta d theta divided by, in the denominator, 1 plus, what is z square? 1 plus tan square theta. This is your 1 plus tan square theta. Okay. So let us use the formula from trigonometry. I is equal to integral sine sec square theta d theta divided by, what is 1 plus tan square theta? This is your sec square theta. So here you can cancel this sec square theta, or I is equal to integral sine, this is your d theta. I is equal to integral sine d theta. Okay. So what is integration d theta? That is theta. So I is equal to, this will be theta plus c. If it is integral sine dx, then we can write x. But if it is integral sine d theta, we can write I is equal to theta, and plus c should be there. Now we can put the value for theta here. If z is equal to tan theta, what is theta is equal to? You can write it in terms of inverse circular function, that is tan inverse z. Or I is equal to, this is your tan inverse z plus c. But you have to write down the answer in terms of x. Again, what is z here? Z is equal to, this is e to the power x. So here you can write I is equal to, this is tan inverse e to the power x plus c. So this is the final answer. So this question is also very, very important. So you can revise it at home. Okay. So now this much is for today. त आज हामीले जति पनि प्रब्लम्सहरुहरु सबै घरमा रिभिजन गर्नु, होमवर्क देख पनि गर्नु. So in the next online class we will do more problems on this trigonometric method of substitution. Okay. So this much is for today. You can copy it.